handful of organisms in there causing toxin production or something. But nonetheless, they have it. And so if you have a healthy enough immune system, you may clear it. But I think the true test is when you have a follow-up, can be years later when you're on antibiotics for something else, and all of a sudden it wipes out, and these spores that can just lay dormant forever. They just kind of hide out in there, in your colon, can germinate. And so it may be clear, you may have a clean, oh, I don't see any toxin, I think she's clean, and then bang, she's on antibiotic, and then it explodes again. It's like, well, you know, she's still, yeah, there's still some.
And they don't come out, they're not gonna all come out.
Well, they typically hide in the cryptic, the little caverns of your, you know, the colon is, for maximal absorption of nutrients and water, there's a lot of folds, and so they can kind of tuck away in there. Hide, yeah.
And could it be sometimes too that they're treated with an antibiotic that wipes out the infection?
Oh,
But-
that's right.
Right, and then they take them off the antibiotic.
I think that's the true test, right?
Right, it's kind of
They
the
treat it,
best
and then they say, I think you're clear.
Yeah.
We'll see, maybe you read about it. And then 3 years later, I was on antibiotic for a knee transplant, and she developed C. diff again. And that's why I work with this bug. I know I'm colonized. That's why I don't want to take antibiotics. I don't want to be that guy in the toilet. No.
So, that was my question too, so is.
Me on the toilet?
Yeah, no. So if you're like a semi-healthy caregiver and you go into someone's room in the hospital that has C. diff.
Yeah.
I mean, there's lots of precautions, right? You're all masked
Yeah.
up and gowned and everything. So how would you get it? Is it fecal to oral or is it?
Yes, fecal oral,
airborne?
definitely,
So
and
it's just
all that
like
stuff.
touch?
Yeah, you'll read epidemiological studies. Okay, a hospital in Quebec did a study where they made health caregivers, you know, like you said, go in a room, gown up, shed everything right there, and then, you know, wash your hands and go to the next room, and that drives down the infection rate, I mean, tremendously. It's because health caregivers, while they might have gloves on, may pick something up, the spores may be in the room, and you go to the next room, and then enough sheds to where these patients ingest it, you know, orally or, you know, breathe it in, and then the spores make their way to the colon and then set up shop that way. So yeah, it's certainly a fecal oral transmission.
So what if you're immune compromised and you go into the room as a healthcare?
Yeah, that's a good, I'm sure the healthcare providers are like myself in that, but depending, it could be a good thing.
Yeah.
Your body has been seeing a lot of it at a younger age, and so by the time you're older and on antibiotic, you're able to fight it. At least I'm the one with that. So, large cluster, we've already talked about those a bunch. Oh, but my point is that dipsil also produces these. Oh, this is what I wanted to show you. And so we put out a paper a couple of years ago showing that, in this case, we're looking at the effects of ciprofloxacin. So that was an antibiotic heavily used in the 1990s, most commonly prescribed antibiotic. And so we were working with 2 strains of dipsil, one that was resistant to ciprofloxacin and one that was sensitive to cipro. And we showed here, this is the one that's resistant. You can see the huge minimum inhibitory concentration of the MIC. It took this much to kill it in vitro. That's a ton of drug. And we showed that when you treated this organism with sub-inhibitory doses, not enough to kill it, but to really make it angry, you could actually induce the bug to produce more toxin than if the bug was just growing all by itself. And so, and this is in comparison to the historical strain, the sensitive strain, that you can see as you increased ciprofloxacin and looked at the concentrations at 24 or 48 hours. Again, this is still a sub-inhibitory concentration. You can see with time, or both times in different concentrations, the bug starts to die. It struggles in the presence of antibiotic. And so we have a grant out for this too. So we hypothesized that perhaps the mechanisms associated with developing resistance, whatever these things are picking up and however it's doing that, may also be associated with some sort of offensive response, that if you treat it with a sub-inhibitory dose, something it doesn't like, it may also try to fight back with that. And so in this case, the minimum inhibitory concentration of the dose it causes to get rid of these bugs in vitro or in a petri dish happens to be sub-inhibitory for this creature, for this bug. And so if you were patient X and you wanted to give them ciprofloxacin, not knowing what strain of dipacil they had, you could actually, say, contribute to worse outcome. You could actually coax these bugs into producing more toxin, making it more difficult for patients to, well, not only deal with the infection, but to get rid of it. So it was this paper that we put out that these pharmaceutical companies now contact us and say, does our antibiotic do that? And so for them, it's pittance. And so we get this money and we do these tests. We get to show one that does, and I think it's because none of the bugs are resistant to it. They're so new, they're not able to have that response. So, which is interesting again. So we believe there is an overlap with this resistance and this offensive reaction to the antibiotics. And so we have a grant out to study the signaling mechanisms, this overlap. We're trying to identify players in this overlap, and then if you could develop an antibody that would interfere with that, you could kind of kill two birds with one stone with these infections. And that's it. That's my talk. And so I'll leave you with this real quick. Special thanks to everybody that helps me out, and especially this Idaho INRI. It's something I'm going to describe to you guys because you guys should take full advantage of this, okay? This is a grant that the state of Idaho received from the NIH, and it's grants that go out to states that are underrepresented in the United States in terms of research in the NIH. And so like Montana, South Dakota, Idaho's one, of course. Get these grants or get money to help stimulate interest in young people like yourselves into going into research. And so every summer at the VA, we probably get 3 to 5 INRI students, INRI summer fellows that receive money. I think it's up to $6,000 for the summer. And so you get to come into in our case, the VA, we give you a project. You get to work on this thing for 10 weeks, and then we go to a conference with all the INRI students, and you present your poster and stuff. But you get $6 grand, and then I don't know what your aspirations are, if it's med school or physical therapy or whatever, but of all of the INRI students that I've had, the 5, they've gone on to their medical schools or PhD programs of choice. I think it's because of this experience. And so most of them have been on a manuscript that we published, and so when you go into your interviews, people say, well, you've been on a publication, and they want to hear about your research, and they find that so interesting, and you stand out in a stack of applicants. And so it's really helped these young people come through our lab. And I think most people are not aware of this opportunity that's out there for students from the state of Idaho. So if you go to this website, it'll say, it's too late now because we're selecting people for this summer already, maybe next year or future years. You just go to the website and say, I would like to apply for a summer fellowship. And then you describe, I'm an undergraduate, I have interest in this, and I want to work with Mike Aldape at the VA or Cheryl Jorsick at BSU or someone at the U of I or wherever. You can, it's a great opportunity for people. And if it's not through this, I would highly encourage. My boss has a hard time saying no, and so we usually have a few more students in our research lab because they want experience doing research. And it's really that experience really helps you stand out to take the next step with your young careers. So do that.
And there is faculty at CWI who help guide students on this.
Oh, do they? Okay,
One
good.
of them is the Teresa Rich, who teaches introductory microbiology. She's one of the microbiology professors. But she's one of the contacts on campus.
I think I've gotten a couple of emails about that.
All right, okay, good. Okay, thank you very much, everybody.
Speak back and shut this down.
Any questions? Do you guys have any more questions?
I have one.
Oh, yeah, sure.
So, I know one of the things that they looked at on Clostridium is like developing a inoculation for it. Is the difficulty in developing something like that because